Okay, well, it's the weekend, and every week we take out our plastic garbage and we put it in the pyrolysis machine, the best blessed plastic to oil machine. And so today is no different, although it looks like it might rain, so I might have to bring this indoors in a second. But let's get the plastic that we don't want to end up in the landfill or actually in the ocean, because that's where most of it is ending up right now. All these number 7 plastics that we don't know what to do with at society. Let's get them in the pyrolysis machine, including all that icky dental floss. Yeah, there's something there. With all the wrappers, food wrappers, all these food wrappers. So there's some plastics that are really easy to recycle, but this stuff isn't considered easy to recycle. It actually is easy to work with, though, because pyrolysis does a great job of turning it back into oil. And it's really a crime that more people don't know about this solution to all sorts of problem plastics, so-called, like food wrappings, aluminized mylar stuff, pizza, pepperoni stuff, the icky stuff, but that stuff turns into oil so well and leaves a carbon black residue. The aluminum gets left behind. And so it really is, to me, confounding that society is still polluting, despoiling our beaches and our coastlines and our coral reefs and our beautiful oceans with stuff that can so easily, like this toothpaste tube, right, which has the aluminum on the inside, that can be so easily turned back into oil and then used in a variety of ways. And the fact that society hasn't embraced this, it baffles me, because it's just a metal chamber. That's all it is. And so, why hasn't society embraced the simplicity of this elegant solution? Normally the bottle caps we keep because that's either HDPE or polypropylene, and we can make signs out of that, so that's easy to recycle. But occasionally it makes it into the number 7 problem plastic bin, and we don't mind turning it into oil. The only thing we can't turn into oil that we have in abundance is the polyethylene terephthalate, the PET. So that doesn't go in. Different melting temperature, nor would, of course, the wood, although that part there, wait a second, I gotta tear it off. There we go. This part here, this can go in, even with a bit of paper in it. All right, and so I think we're pretty good. Let me take off my gloves. Sorry for the bad camera work. I gotta set the camera up and take off my gloves, put them in. There we go. So off goes the glove. Kid gloves are off. Okay, and then I put on you won't be able to see this yet. All right, I gotta put on the top to the retort there and line up the holes. And this is going to be solar powered pyrolysis, because the property, thanks to the bishops, is completely solar powered. So the energetic costs, which are always favorable because you get apparently 2 units of energy out for every 1 unit of energy you put in when you're doing plastic pyrolysis. So it's a 200% yield. But since this is solar powered, we don't worry, even if it was at parity or worse, because we're doing a good. We're eliminating plastic waste that would contaminate our ecosphere and cause problems to our tourism industry, problems to our wildlife, problems to our aesthetics, problems to our air when burned. And so we want to turn it right back into the oil from which it came. I gotta make sure that this is right, and that's not quite seated right. Hold on. Hard to do camera work with one hand, isn't it? I know. I should get one of those. I actually have one of those things that you hang on your neck to hold your phone. But, you don't want to prepare for everything in life. Sometimes you're out there doing the work and you're like, oh, I should document this. I'm not going to spend too much time worrying about the aesthetics of the production quality. All right, so that's tamping down, that's tied down, that's hand tightened down. Okay, so there's that. Now I got to put on the replacement vessel. There used to be one here that came with the company. It broke and it shouldn't have. Oh, I missed getting that piece in. So Russell watch us rig this up out of the mason jar. Let's bring that carefully over. Oops, and I got to get this out of here. The O-ring. All right. So let's put that in its place. It's got oil from the last time I used it, as you can see. So every week I'm doing that much. That's about how much we accumulate per week. Oh, that fell down. And so that's what I'm getting. I'm getting about 500 milliliters of oil, plast oil, per week from that much plastic, which is about our week's worth. All right, so now let's get this O-ring on here and then place this. Oops, I'm gonna have to put the camera down again to do this. Get this. Whoa, there's the camera. All right, whoops. All right, so yeah, let's see if we can. Where'd my hands go? Oh, it's looking at the wrong direction, actually. All right, so there we go. So we seat that, and let's get the clamp on there. And tighten the clamp over that O-ring. Overpressure relief is here. Okay. Just tighten that down. So it presses onto that O-ring and hopefully it makes a good seal. And then let's hook up the hose to the catalytic converter. And that's all she wrote. That's loaded. That's done. So now let's touch the screen here. And let's say that it's going to run and set the confirmation, and it's going to ask me, or it should touch me, did you close the cover? Yes, I did. Is the water fixed quantity? Yes, it is. Did you set the hydrogas filter? Yes. And now mode selection, commence, and it should be starting to heat. All right, so we'll have another batch of plast oil in just a few hours. 3 hours is what it takes as this heats up. And I'm going to come back and check this when this top of the retort and bottom of the retort reaches about 212 Fahrenheit. I want to make sure there was no water vapor in there that stalls the gradual heating. And then once it gets over 212, then I can leave it alone. Unless it rains, then I got to drag it in under some shelter. But now that it's slowly heating up, filter eventually goes on once it starts doing pyrolysis. There's the upper and lower bound temperatures in Fahrenheit, and this will fill up with a yellow color indicating that it's running, although it's just a timer. But this is going to jump up. First, it's going to drive out all the air as it slowly heats up, get rid of the oxygen in there that could be explosive. Then it'll heat up a little further and drive off all the water vapor, and then it'll go into pyrolysis mode. So yeah, we'll get another batch of oil. Then it looks like after today's run, we'll probably need to drain this out and put it into a bottle for storage. We like to store our oil. We've run the weed whacker here on it for a couple of weeks, and then we up the carburetor and the spark plug, and so we've got to repair that. We still want to repair this old lawnmower to try it out, and that was on 100% plast oil. And there's all my bottles of plast oil from this summer's experiments. So there, we got plenty of it, you know, but we're storing it like oil. I mean, it'll last forever, so millions of years. So you make it and store it, and then we'll get better at how to refine it better for different applications. But right now we want to keep the plastic as something of future utility. That is the idea. And yeah, so very little to it from now. Just gotta wait. Just gotta wait. All right. So we'll do that. The other thing we've got going on today is we have a new plastic press that Brian brought from the office, and then TR brought to the welder, did a design so that we can try to create our own signs. This is a $5 sign that we carved on the X-carve over there, and we don't want to be buying signs. We want to make our own out of recycled plastic, because after all, this is just HDPE. It's kind of warping too. So why buy when you can make, and you've got an abundance of plastic? Just like with our aluminum, we take our aluminum cans and we melt them down in molds, and we can make cool shapes out of them. So why would we give the aluminum away? All right, and then there's the material I use to make the signs. There's the oven that I make them in. Hi, Manolo is asking, how much does the needed equipment cost? Well, the plastic to oil machine from Blessed in Japan is not a commercial item for domestic use. So they sell you the classroom or desktop demonstration model here for a whopping $13,000 under the assumption that you will then return it and accredit that $13,000 to buying a $500,000 or $1 million machine larger than this entire shed that does a half ton or a ton or 2 tons a day. And this only does a kilogram a day. So they're banking on you sort of doing a down payment by getting the machine. It's a ridiculously high price for something that's basically just a stainless steel chamber with a heating element, a little controlling computer, a catalytic converter, and a glass vessel, which used to be here. I guess the catalytic converter is the big cost, because it probably has, palladium and platinum and who knows all what else to make it into carbon dioxide and water, because otherwise you'd have toxic vapors coming out, and this breaks it down. So that would be the high cost. But I think you could make one yourself, and I wish I had a team of allies in the know to do it, because we would just get any stainless steel chamber, and then we would a bath of water, and probably get a catalytic converter from an automobile, and we should test that out. So that's the deal there. It looks like my battery is going dead, so I'm going to have to end this broadcast. But thanks for watching, and I hope you'll do investigations and eventually join us in this mission of eliminating plastic. Okay, goodbye. See you later. Thanks.